Okay, so over the page, number 3. Okay, stem and leaf. So this is the one I said that you actually may well be better at than me.
This is on both.
It can be on both. Did it come up on Wednesday though? If it didn't come up yesterday, we'll expect it to go up tomorrow.
It'll be like the first question.
Yeah, I would have thought it'd be pretty early on. So 1, 2, 3, and 4. Tell me if I'm doing it wrong, because I've not done one of these actually before. Is this looking good for my one? Yeah? Is it meant to be in order?
Yeah.
Ah, there we go. Well, thank you very much. Ah, excellent. Well done. Pick up on really, really key parts there. Okay, so I'm going to have to draw a new one, aren't I? Because I've done it in pen. I've messed things up. So make sure you read the question. Can you remember at the start I said one thing I would never do is actually read the question? So when you're doing it, do you just go through the whole list and look for the lowest one then, do you?
Yeah.
So I've got a 16, so that should have been 6 and 8 there.
And then cross it off.
And then cross it off. Okay, that makes sense. So I've got a 21. Is it a 20 anyway?
I always like circle with different shapes, like different shapes.
That's a really good idea. So for 21, I've got a 28, a 27, 25. Any others? 28 again. So I should go, is it 1, 5, 7, 8, 8?
Yeah.
Oh, okay. Very good. 3, so I'll square those ones then. I like that idea of different shapes to differentiate between. So we've got a 30, so 0, and then 3 6s, and an 8. All good? And then 48s, triangle. And there. So what have we got? We've got a 1 and an 8 and an 8. Is that looking good?
Yeah.
Yeah?
So you need to count up
There's
on
a
your
five.
cross.
So
There's a lot as well. Yeah.
Have I missed that? Where have I missed that? There. Oh, well done.
You need, so you got to count up once you've like put them on it, so you know you haven't made mistakes.
So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There we go, the age of 16 people. Well done. So obviously if I had missed out that 5, I would have counted 15. I missed one.
Yeah.
Okay, good. Oh, thank you. You were much more useful than I was in that. What do I have to write in where it says key?
So like 3 lines. Do you like yeah, pick a number, yeah, so off the chart.
Yeah?
So write it.
So 16?
Yeah, do 1. Then put equals, then put 1 and then a line, and then 6.
Ah, okay. They teach you how to do 7 leaves.
Pardon?
They teach you how to do 7 leaves. They're all sorts of it.
You want it?
No, they're doing something. And it sounds nice. Oh, miss, I can't believe you're so mean. So median age is the middle age, isn't it? What's the middle of 16?
8.
Are you sure?
No, you can't.
You would think it is 8, but it's not, because you've halved it. When you're doing very, very big numbers, that's exactly what you should do. But if I did actually have 16 numbers written out, let's say if I choose an even amount of numbers, so if I choose 6 numbers, so 1, 2, 3, 4, 5, and 6, if I'm to cancel first and last, how many numbers are in the middle? 3 and 4. There's actually 2 numbers. Whenever you have even numbers, there's 2 numbers left in the middle. So when I had 6 numbers, if I halve that, 3, and the one afterwards, excellent, it would be the middle of those 2 numbers there. So in terms of this one here, 16, there are 16 numbers there. If I halve that, I get 8. So I'm looking for the 8th and the 9th number. Okay? So 1, 2, 3, 4, 5, 6, 7, 8. So my 8th number is 30, and then my 9th number is 36. So what would be the median? Excellent, well done.
I have an easy way of doing that.
Go on then, what's your easy way?
You cover the numbers up.
Yeah.
And then count backwards, and then until you get when you end up with either one, that's your.
Yeah, okay, yeah.
The two.
You could do, yeah, that's a nice idea. I might try and do that in pencil rather than pen. Got a pencil here. What's that, sorry? So yeah, what I could have done if I did it in pencil is start crossing off first and last from my drawing there. So first and last, first and last, first and last, first and last.
So why'd you half it?
Why do you halve it? Because it's in between two numbers, isn't it? I'm left, if I did cancel the first and last every time, I'm left with two numbers. So if I did cancel off that one and that one, I'd be left with nothing. So I've got two numbers, so I just find in the middle of those two numbers. Okay? Okay then, number 4. Bob has 120 beads. The beads are either red or green. Bob gives 3/4 of the beads to his friends. 2/3 of the beads Bob now has are red. How are we going to work out how many green beads Bob now has? Okay, so we need to try and do a few things. What should we start doing? What might be a good idea to start getting some marks on this?
So, do you divide it by 4?
Excellent, you're finding 3/4. There's a couple of ways of doing that. And dividing it by 4 finds 1/4, times it by 3 finds 3/4. The other way that you can do it into your calculator is you can press this button here and say 3/4 times by how many beads? So times by 120, but doing your way will work as well. Do whatever you're comfortable with, okay? Anyone seen it this way before? No?
Yeah.
Okay, well I was trying to show it so anyone who had seen it to be comfortable with it, okay? 90?
Yeah.
So I need to say what I've done. 3/4 times 120, or I could have said 120 divided by 4 equals 30, and then times it by 3 is 90. And what's he do? Bob has 120 beads. They're either red or green, and he gives 3/4 of the beads to his friends. So he's given away 90 beads, isn't he? Great. So I'm going to say 90 beads given away. Just for my own head more than anything else. 2/3 of the beads Bob now has are red. So how many are green? It's very, very similar to what we looked at before in terms of probabilities adding to 1. If 2/3 are red, that means that 1/3 must be green. Agreed? Because 2/3 have 1/3 is 1 whole. Work out how many green beads Bob now has. So I need to do 1/3 of how many he had left. So he's given 90 away, so how many has he got left? Good. So he has 30 left. So the way we worked that out was doing 120 that he had, but he's given away 90. That equals 30. And then 1/3 of those are green. So how am I going to find 1/3 of something? Fantastic. Either doing 30 divided by 3 is 10, or you could use the fraction again. You could say 1/3 times 30 equals 10. Either way, you get 10. Okay? Anyone want me to go through parts of that question again? Just double check that we know what we're doing. Okay, so in hindsight, I think it's a good idea to go and written that in straight away. It says 2/3 of the beads Bob now has are red, so that meant that 1/3 were green, because 2/3 of 1/3 is 1 whole. Work out how many green beads Bob now has. So originally he had 120. They were either red or green. He gave away 3/4 of the bead. So he gave away 90. We worked out 3/4 of 120 is 90 beads. That's how many he gives them away. So that meant from the 120 that he originally had, taking away 90 meant he's left with 30. Okay? So he has 30 left. And then because it's 1/3 of green, we either divide that by 3, or we can just say 1/3 times 30 does the same calculation. Okay? Okay, down the bottom, what do we need then to do that question? Tracing paper. I can't do these tracing paper. Some people can, it always surprises me when people do it. Oh, it's just obvious, isn't it? It's like, no, it really isn't.
But actually,
I still can't do it.
yeah,
I taught it. It is possible. I'm not arguing it's not possible. I'm just saying I find it
You can do it without it, but you don't know what you know.
I find it hard. Okay? So, I'm going to show you a couple of things that I do, because I don't do it quite the same as everyone else. I do it pretty much the same as everyone else. It says, rotate the shape clockwise 90 degrees, centre O. Sam, how are you doing? You alright? You're going to head off, you? Yeah. You don't look the best today. You don't look the best. I've seen you looking happier. I've seen you looking a bit perkier. Yeah, sure. You stand back in that. Right then, so what I do is I look for the centre O and I go and mark it here first. And what I like to do myself is I go and draw a crosshair on O. But it's sort of done there for me already because it's the axes. But if it wasn't, I'd just go and draw, like a sniper thing on Call of Duty. Yeah? No, not anymore. Too old, too boring now. Oh, rubbish. When you trace the shape, you need to also trace your centre and the crosshair. If you do that as well, it will make rotating this by 90 degrees very, very easy. In fact, it will make rotating it by 180, by 270 very, very easy because that crosshair will do all the work. Go on, Lloyd. Say again.
So you don't have to do the lights back up.
For which one? For this bit?
Yeah.
No, you don't need to do anything with that.
No, when you turn it, that's when it starts.
Spot on. That's exactly right. Yeah, sorry, I'm with you. So when they match up, that's going to be doing it in 90 for me. If they match up twice, that's going to be doing it is for 180. I have to go to pen. And 3 times would be 270, okay? So what you do is you put your pen on that point there, and then clockwise would be going this way. And I must do it clockwise, so it said do it clockwise. If it said do it anti-clockwise, I'd do it going this way. Okay? So, clockwise, can you see here now that crosshair matches up on itself just like Lloyd said? When it matches up on itself once, that's 90 degrees. If I did it twice, it'd be 180. If I did it 3 times, it'd be 270. And if I did it 4 times, it'd be 360. It'd be back to itself, wouldn't it? If you spin around 360 degrees, it's in a full turn. Okay? So, it's that one there. So I mark through there on my paper, so hopefully I can see when I remove the trace of paper where it was, yeah. And then the one thing I always do just to make sure I'm definitely going to get the marks, I'd hate to lose one of these marks or both. Shade it in just so it's really, really obvious, and then I put my trace of paper back over. So I match up again, the crosshair goes on the crosshair. Look, it matches up perfectly, so I know I'm right. Okay, so I can leave that exam. Now I've got the 2 marks, as long as I've done 90 degrees and clockwise. Okay? Okay, this is a fussy question. This isn't easy. Okay, what is surface area?
The front triangle you see. Like.
That will be what we call area of cross-section. Okay, good knowledge nonetheless. You need that for the volume. What is surface area though, boys? Any ideas? Lloyd, Will, any ideas? Surface area?
For surface area, don't you do a cross section?
Not quite.
Isn't it if you start to cut it, it would be the same width?
Okay, you're still talking about cross section, yeah. If I
Base
cut that,
times height.
going back every time, I'd see that triangle every time. We're starting to get somewhere. Go on, say again.
Half times base times height.
Now that will certainly work out the area of the front triangle for people. What is surface area?
A squared plus B squared.
Don't need to do that as well. We're doing loads
The
of stuff.
area of the entire shape.
The area of the entire shape. Think of a cereal box. My dad used to go nuts if I used to go and put the cereal box just in the bin. Your parents do the same? No, my dad used to.
Yeah,
you
you've
need
got to fold it.
Yeah,
crush it
you've got to crush it up. Basically, you know where it glues. You go and run your finger down there, open it up, and then just like fold it down and rip it up, so it doesn't take up quite so much space. So that is what we call the surface area when you unglue that cereal box and you open it up fully. So we need to think what this would look like if we opened it up fully. So that base rectangle there, I'm just going to draw by here. So that base is 15 centimetres going across, and it goes back 10 centimetres. Happy with that? That triangle then, here, that's going to fold down to here, like that. And that's 8 centimetres there, and it's 17 centimetres here. I'm starting to wish I'd drawn that a bit better now. What's going to go on at the side here? Well, this rectangle here is going to fold down to the side, isn't it? So that side there, being 8, is just going to fold down here. So here would also be 8 centimetres, and it would go back the same as that length there, which is 10 centimetres. Okay? What's going up the back? I've got another triangle. So that would fold out. Look like that again. All good? And then this one here, now this is 17, isn't it? That's going to open like a trap door, and it's going to fold down by here. So that's going to be the longest one there. And that's going to be 17 centimetres by 10 centimetres again. Are we happy with that shape? Happy I got it. Okay then, now for me, I go and call those rectangles different letters. So I'm going to call this one, you get a mark for doing the next bit, you have to visualise that bit. That's one of the hardest bits about this one in particular. I'm going to call this one A, this one B, this one C, I'm going to call that one D, and that one E. Okay, so the first three are actually pretty simple, but Will's already done the hard work for us for D and E. So he's already told us what the formula is. What are the dimensions of rectangle A in my drawing?
Dimensions.
So what's its base, what's its height, or what's its length, what's its width?
The front one.
So this one here. 10 centimetres by 8.
8 centimetres square.
Good. And show your formula that you did to get 80. I heard 80 a second ago, well done. Just show me where it's come from, say 8 times 10. What about for B? Tell me what the formula is.
50.
Excellent, well done. 15 times 10? 150 centimetres squared. And for C?
17 times 10.
Spot on, you're all over it. Which is 170. Now for D, slightly harder, but Will, what was that formula again?
Base times height times width.
Not quite.
Length.
You would find a volume for me of a cuboid. You said before, I'm pretty sure you said half base times height.
Half base times height.
Yeah? So it's basically, because it's a rectangle but it's cut in half, that's why we halve it. So what is the base of this triangle, looking at it here, the front one? 15, what's its height?
8.
8, the 17's got nothing to do with it. When we're looking for height, we're looking for the right angle. So 17, in terms of working out the area of the triangle, nothing at all to do with it. So it's just 8 times by 15, and then a half of that, to divide that by 2. Okay?
60.
How do you know that?
I already did it.
You've already done it in your calculator, have you? I was just going to stick it in here. Well done, it sounds about right. Oh, very good. 60 centimetres squared. And then for triangle E, why is that good news that we've already got 60? It's going to be 60 as well. It's going to be the same formula. The point is writing the same formula again. I'm just going to say 60 centimetres squared. Okay? Okay, then so how would I work out the total surface area?
Would you add a 80?
Fantastic, you just add them all together. We found all their individual areas, so if we add them all together, we'll find the total surface area. All good? Then well, that's really good. That's 4 marks as well. Definitely stick this into your calculator. Yeah.
So when you do the triangle bit,
Yeah.
why didn't you divide it by 2?
Because a triangle, so if I draw a rectangle that is 15 by 8, This rectangle here, how do I work out that area? I'd do 15 times 8, wouldn't I?
You could
The
just
triangle is cutting that in half. So basically I just need to half that area.
You could just do it in.
All good?
You could just do an all one page of equations. You just do 8 times 15, and then just do it.
Two triangles, yeah. What a good idea. Whatever works for you. Okay? Yeah, in hindsight, yeah, good idea. Okay, so I've got 80 plus 150 plus 170 plus 60 plus 60. 520?
Yeah.
Yeah, agreed.
You know this box underneath? You're not to write it.
Yeah, I think so. It doesn't say you can't.
Because I asked him originally, I asked him to do the exam, and he took about 5 minutes to answer me.
Unless it says, look, it says by here at the top right, it says leave blank. It doesn't say anything there. I think that's absolutely fine to write in that, yeah. 520 what? Coconuts? Bananas? Centimetres squared. 4 big marks if you can get them. Time consuming, yes. Time consuming, yes. Hard?
No.
For me, I think it's more than doable. Bit of algebra.
Easy.
Do you want to have a head start on that?
Yeah.
Ten of us. What's your name in front? Sorry? Joe. I'm a big fan of doing what Joe did for the stem and leaf with these. I put like circles around certain letters. So I put a circle around E and then a circle around any other E's, but you must include the sign in front of it. If you don't, you'll mess it up. And then I'm going to do like a square around F's. Okay, so 6E plus E, 7E, plus 5 take away 3. 2F, what sort of 2F? Be a positive, because we're on positive 5 take away 3 would leave us on positive 2. So if you just say it's 2F, it'd be just a plus 2F. All good? Does it matter which way around I write those? No. You can write 2F plus 7, it's the same thing. Yeah. I would have, obviously as I say, I would have written the E first, I did. And the reason why I did it was because it came first there. Okay. Part B, you do see that messed up quite regularly. What's that 4 have to do? Good, times by both of them in the brackets. So 4 times 2x, 8x, 4 times minus 1. Excellent. From here, you happy what to do here? Do you want a bit of a hint?
Yeah. I just want to check.
The hint that I give is look for your smallest x, move it, or get rid of it. Do you take things away from both sides, or do you change sides?
What you do show, you switch the 4 with the 3x.
Yeah.
So it becomes plus 4. Does it say minus 3x?
It becomes minus 3x. At the moment, that 3x hasn't got a sign in front of it, which as we just saw, when it doesn't have a sign in front of it, like we just said, it's a positive. So when that goes over, it becomes a minus 3x. So we happy do it that way. I don't want to confuse you from the way you're currently taught. Some people may look at it and say, take away 3x from both sides. Is that's what some of us have heard?
Yes.
I'll tell you what, I'll do it both ways. Okay, so if I was to take away the smallest x, so you're looking for the smallest x, 8x, 3x, 3x is smaller, take away 3x from both sides, that'll leave me with 5x minus 4 equals minus 19. Then I want to get rid of minus 4, so I add 4 to both sides. So I get 5x equals minus 19 plus 4, minus 15. How do I get rid of the 5?
Oh.
15 divided by 5.
Minus 15 divided by 5, yeah? Good?
So it'll be minus 3 answer.
The answer is minus 3. X equals minus 3. Okay? If I went and did it the other way, I'd say swap the 3x. Why the 3x? Am I swapping that one? Why?
You want all your x's on one side.
I want x's on one side, numbers on the other, but I want to take the smallest x over. That's how it works. So that 3x coming over to the other side will become a minus 3x. We'll get 8x minus 3x. Here, that minus 19 stays as minus 19. The minus 4 goes over as a plus 4. So I get 5x equals minus 15. So x equals minus 15 divided by 5. So x equals minus 3 that way as well. They both work. So whichever one you like the most.
The other third one, so
Yeah,
to start it, so the 5's on the bottom, do you take the 5
excellent. Because the 5 is dividing everything on the bottom here, not just the y, the plus 4 as well, that's the thing we're getting rid of first. So method 1 is that I times both sides by 5. So I'm going to get y plus 4 equals 30 times 5, which is 150. Take the get rid of the plus 4. Take away 4 both sides. So y equals 146. The other way to do it is that you say,
So I can't see the bottom of the page.
sorry, all good? Okay? So it's whichever way you use, and you've used the last few years, don't change today. It's the worst thing you could do. Okay, so hopefully I've shown either way that you've done it for, yeah?
So I was just
150, I times both sides. Which one do you prefer, left or right? The left one. I times both sides by 5 because that was a divided by 5, and 30 times 5 is 150. Okay, you good? I'll tell you why you should be looking at it and thinking, God, that seems like a weird answer. Well, why do you think it looks like a weird answer? I know why I think it looks like a weird answer. It's massive, isn't it? We're used to the answer being like 3, maybe minus 3, maybe 8. Not 146, but that is 146. And there's a way that I can check. If I'm telling you that y is 146, if I put that in place of here, if I say on my calculator 146 plus 4 divided by 5, what should the answer be? 30, because that's what it says it is here, and I've just said why is that? And look, when I press equals, it is. It's a nice thing with the calculator paper, you can actually go and check to see if you're right. Okay? Same with this one here, if I wanted to, I could go and put minus 3 in there. It's a bit fussy because there's x's on both sides, so I'd have to find the left-hand side, then the right-hand side, and see if they're the same answer. All good?
Just estimated into
Just trying to think of the best way of doing this one. So basically, the reason why this has been put into a table is because you've gone and asked 32 people. So if I went and asked 32 people how many children they had, and then sort of like wrote them out and said, right, 0, 1, 2, 0, 1, 0, and so on, I've got this really, really long line of data, and you saw earlier we did a stem and leaf diagram to sort it out. This has already been sorted for us. They've said, look, there's 9 people who have no children. There's 6 people who have 1 children. There are 7 people who have 2 children. There are 8 people who have 3 children. And 2 people who have 4 children. And no one who had more than 4. Yeah?
Is this the one where you have to like do 9 out of 6 and then that answer by add 7?
Pretty much, well done.
32.
Good. Okay? Now, there is no midpoint. We're just going to times already. They've sort of done the midpoint for us. No, he's right, he's right. So, in terms of what the mode is, what's it mean to be a mode? Most occurring. Which one has got the highest frequency? Which one is the one that most happens? The first one, 9, which is the frequency which belongs to no children. So to find the mode, the answer would be 0, or 0 children. Okay? 9 is its frequency, 9 is the most occurring. So that means the most number of people had no children. Okay? Now the next one, calculate the mean. The reason why this has been put in a table is to make things easier. Will, can you pop the phone away for me, please? Thank you. In terms of calculating the mean, if I had it as a long list, so say I had like 0, 0, 0, 0. I had 9 of those, then I had 1, 1, 1, and I had 6 of those, and so on. What I'd do is I'd add them all together, find out what the answer is, and divide by how many people. Agrees? But they put it into a table to make it easier for us. In terms of if I've got 9 lots of 0, I can just do 9 times 0. What is 9 times 0? 0. There's 9 people who had no children. Get those 9 people together. How many children have you got now? There's still none. There's 6 people who have 1 children. So if you times those together, that's 6 children altogether. 7 people have 2 children, so 14 children altogether. 8 people have 3 children. That's the household I was from. Anyone else got two siblings? Have 3, so you're one of the 4s, are you? And then 4 and 2. Have you got a brother and a sister, or 2 brothers, or 2 brothers? One of each. Just a little interesting fact for you about me. And then, more than 4, 0. So if I times that, that means there's no more children there at all. So how many children are there altogether? So I'm going to call this number of children. Or say no of children. 52. So we've added up all of those together to get 52 children. How many people were asked in the experiment? 32 women, wasn't it? So to work out the mean,
52 divided by 32.
well done. It'd be 52 children divided by 52 women. Sorry, the 32 women. Which is going to give us a weird answer.
1.625.
Now, obviously, you can't have 0.625 children. If it was me, I'd just round it to 1 decimal place. Okay, there's a very famous TV show out when I was about your age called 2.4 children, because that's what the average number of children per household in the United Kingdom was. So for me, I'd be doing that as 1.6 to 1 dp, but I'd say in here 1 dp to show that I've rounded it. Unless it tells me to round it anywhere, which it doesn't, it just says calculate the mean. But for me, it would be acceptable to round that to 2, but you'd have to say round it to the nearest whole number, which takes much longer than writing 1 dp, which is why I round it to 1 dp because I'm lazy. Okay? All good? Ah, good. I was hoping this would go up. I was hoping that would be on our list of things to do, actually. I sat down. Have we flown through it? We've done well. Bell's not even gone yet, is it? It's about to go any second. You're in here 1 and 2 with me, and then 3 and 4 were in with Man Centre, 5 and 6 back.
Is it period 2 now?
The one you're having the Marion Centre is. Okay? That's why we're doing this one slightly differently than we're working through this one together. 5 and 6 are here. We've got a list of things that we were discussing at the start that we'll work through as well. And again, film it all, ping it up on YouTube. There. Can you take your earphones out, please? Thank you.
So you're going to try to group this 3 cubed.
Good.
That's 5.
Good.
Times 3.
Excellent. Now that 5 times 3, just right, you've said it, it's fine. Okay? When you're doing your trial improvement, it's really important in your layout that you do a decent table. If you get your tables sorted, it more or less solves the rest of the question for you, okay? So you draw a long line across, skinny first column, really, really fat middle column, skinny last column. Okay?
Do you have to draw tables?
I would if I were you, just to get yourself going through it. You don't have to, but I would if I were you, okay? Here, we're going to say try x equals. Here, we've got x cubed plus 5x equals 67. And here, I'm just going to say comment. So we're going to be saying either too big or too small.
Just to put all that, you can just write the answer try.
Yeah, pretty much. Just x equals is fine. Okay? Lloyd, you started really well. What number did you try first?
3.
Why did you try 3?
Is this
It's in the question. If it's there, chuck those in, because when you're chucking 3 and 4, you get one of those 4 marks. Okay, so 3, first of all, we're going to do 3 cubed plus 5 times 3. Okay, should I put brackets around anything there? Your calculator will probably keep you safe, but I would probably put brackets around that if it was me, okay? And that is going to equal, I've got no idea. So, 3 cubes, 42, which is too low. So for me, it's that one there. See? Got it? Okay, so that equals 42. What's I supposed to get? I was supposed to get 67, so that's too low. So then you try the other one, 4. So 4 cubed plus 5 times 4
It's too high.
Do you know how to do that in your calculator quickly? Just use the replay button. If you start coming right, first of all, you can delete the 3, change it to a 4. And this one here, delete the 3, change it to a 4. Is 84. So that is too high, too big. Okay? Now your marks come in as follows. I'm going to live mark this one at the same time, okay? Too low, too high gets me the mark. That's called an M1, a method mark for getting it to go too low then too high in what we call consecutive numbers. One number straight after the other. Now it says here in the question, it says go to 1 decimal place. You actually go one more than it really says. You actually go to 2 dp, but only once. Okay, you don't need to keep on going to 2 dp, you just go in the middle of the two numbers that we're going to find in a second. What number should I try next? I totally agree. Let's go 3.5, it's in the middle, it seems like a good number to go for. So 3.5, so again replay, 3.5, then 3.5, oh, don't put 35, so I'll definitely get it wrong. And that gives me an answer of 60.375. Is that too low or too high? Too low. So make sure you comment on it. Yeah? Ah, okay. If you're starting to get really, really, really long answers, I just write 1 or 2 of them and say dot, dot, dot to show you carry on. Okay? From here, because 3.5 is too low, boys, thank you. Thank you. Because 3.5 is too low, I'm going to try what now?
3.6.
Not 3.7? Don't skip values. If you skip values, if it goes too low and too high again, if you skip values that are not consecutive, you won't get the marks, okay? So because we start with 5, we were either going to go 4 if it'd been too high, or now 6 because it's too low. Okay? So go in those obvious counting numbers that I sort of used that expression earlier. Okay? So let's change those to 6s, there, and there. So that gives me the answer 64.656, which is still too low. Okay? So now I'm going to try 3.7.
That's too high.
And that's too high. Now if I'd skipped 3.6 then and gone straight to 3.7, I would have actually lost the rest of the marks because I hadn't found that middle one. So 3.7. And that gives me, 69.153, which is too high. So the mark comes in as soon as I go too low, too high again, but they'll come back and check these are consecutive numbers. Look, 6 and 7, they come one after the other. So that's when we get my second mark. How do I get my third mark? Any idea? Go on. Oh, okay, fantastic. Yeah, you beating me. Go on, Lloyd. What were you going to say?
Get the right answer.
Get the right answer. Sorry, Dan, you've got a route change. Have a look on the door. Or don't. Okay, so we're going to go, because it's in between 3.6 and 3.7, we're going to go 3.65. Okay? So 3.65. Now, as soon as you do this, you'll get your third mark. And 3.65, what's that going to give me?
66.
Is that too low or too high?
Too low.
Too low, okay. So 66.87 blah blah blah, which is too high. Too low, sorry. Now as soon as I did that, that got me my third mark. So what Amber has done is she's drawn a table here. She said 3.6, 3.7. Here she found it was too low, so she said try a bigger number, and she did. And she tried 3.7, it was too high, so she said, we'll try a smaller number. So what she did was she chopped that line exactly in half and tried 3.65. Now that answer was still too low. So that means try a bigger number, which means it's going to be closer to 3.7 than 3.6, because I'll have to go bigger again. So to 1 decimal place, it's 3.7, and that gave me my fourth and final mark there, okay? But if I don't do this line here, that 1 to 2 dp, and it was only once, you remember I said you'd only have to do it once, you won't get the second mark there either. Okay? It is, but to one decimal place, it's closer than 3.6 is to it. Good question. Okay? Okay, and number 10A, hopefully something like that will come up. It's literally just a case of making it look replica on your calculator to what it is there. So I'm going to start off by pressing this button here. And no, I'm not. I'm going to start by pressing this button here, then that one. So I've got the square root and I've got the fraction inside it. Then 920 minus 170 tan. Now they automatically bring up a bracket there. Don't worry about that. That's fine. You just got to put a bracket at the end. Okay. If you don't close the bracket, then you won't get an answer that say math error. Okay.
How did you do this? Sorry, I was daydreaming.
If I were you, I'd grab one of those calculators and grab one of them for tomorrow. There's loads in the hall.
Take one now and keep it.
Then my personal. Very kind of you to offer yourself my equipment. Then press the replay button, come down to the bottom, 0.012 plus 0.034, and then I've just pressed equals. Now here, the thing that I would definitely recommend you do is you write down the entire answer first of all. Okay? Now I know it says to write it as a decimal, we'll worry about that in a second. So it's 109.8847047. Okay? Now as soon as I write that down, I've definitely got at least one answer mark because I've got the right answer. What does it say in my thing here? It says you must write your answer as a decimal. It says write down all the figures, so I had to anyway. But usually what I tend to see is that it says round your answer to 2dp or something like that. Write down the whole answer anyway, then round it, because then if you did mess up rounding, you're going to get the mark for that anyway, okay? So that is actually going to be full 2 marks there.
So mine said error.
Yours said error, you didn't close the bracket then in my bet. Go and check you've got a bracket there.
How do you do a degree?
Degree you don't need. Oh, that's a great question, you don't need to. Okay?
How does it tell the next slide?
You use the replay button here. All good?
Yeah, when it says the 3 significant
Will.
figures.
Don't do that, it's irritating, isn't it? Give your answer to part A correct to 3 significant figures.
Would it
What's
just be 109?
fantastic, very good.
I got
Fantastic.
99.84747.
Brilliant, that's what you should have as your full answer. 3 sig figs means you round after that third non-zero number. So you start counting from the first non-zero number. Here, because I started counting, I carry on. Okay, can you make sure you're focusing, please? So 1, 2, 3. Third number. That number there, okay, it's not going to be 9. What's this number here?
Oh, so it'll be 118 and a half.
Good. This number is 8, so it's going to round that up to the next number. So 9 is going to go up to 10, so it'll be 110.
So I thought 0 was not significant.
Now 0 isn't a significant figure before I start counting. As soon as I start counting, they're all very significant. Great question. Okay. Similar triangles. The best way to do this is to find something called the scale factor. Boys, can you do me the courtesy, not talking over me when I'm talking through the question?
Would you use Pythagoras?
You don't need to use Pythagoras, you can't because it's not a right angle triangle for one. Or Socotur because it's not right angle. Sine cosine uses that, but it's not anywhere near the end. Question 11 is about midway. That'll be right near the end, stuff like sine and cosine. Okay? So, because the key word is similar. Okay? If it's similar, that means that this one is just an enlargement of that one. So we find something called the scale factor. Okay?
Or like when it tells you on the graph to enlarge something.
Spot on. So we've got to find what we call a corresponding side that is the same on both. So do we know a triangle where the corresponding side is the same? Well, this one here, 18, but I don't know that side there here. Okay? This one here, 12, but I don't know that side here. However, too much work. Up on the top, come on boys, a bit of maturity now. If you can't sit together, I have to move you up. I don't want to do that today. I want you to work together. Okay? Thank you. if I look at the top one, I know both of these sides here. So this one must be the bigger one, mustn't it? So I've times this triangle by something. The way I work that out is I do the 10, I divide it by the 6 to find what we call the scale factor. Okay, so 10 divided by 6 is 5/3, it's just said on my calculator. If I press SD, it gives me 1.6, but it's a recurring. I would leave it myself as 5.3, or I'm going to leave it as ants in my calculator. Okay, so I'm going to say 5/3, and I'm going to just put an arrow to that and say scale factor. So what I've done is I've times this triangle by 5/3 to turn it into the bigger triangle. So how would I turn the bigger triangle into the smaller one? Excellent. By 5/3. Okay? So when it says work out or calculate the length of BC, BC is this one here. So I don't know that one, so I do know this one.
Times 12 by
5/3, fantastic. So I need to do 12 multiplied by 5/3. Absolutely no idea what that is. So I come to my calculator, say 12 times, fraction button, 5/3
20.
equals 20. 20 centimetres. Okay? For the other one, which is just off the screen here, it says calculate the length of PR. So P to R is this one here. So if I come to the bigger triangle, 18, how do I turn 18 into that one?
Divided by 5.
I got the 5 and 3 by looking at the original two triangles. Because I knew the top and the top on both of them, I did the big one divided by the small one, and that tells you what we call the scale factors, how many times this one is bigger, how many times this one goes into that one. Okay? So for calculate PR, fantastic, I'll do 18 divided by 5/3. Okay? So I get 54/5. If I press SD, I get maybe a nicer number. There we go, 10.8. It's not recurring. It's not got loads of decimals after. It's not got a point on it. So I'm just going to leave it as 10.8. And again, that would be centimetres. The one thing you want to do is just double check. Does that answer seem to make sense with your triangle? If I look at that answer up here, 10.8, would that make sense? I think so. If it was like 20, I think maybe not. If it's like 30, you know, if it's got bigger, much bigger, just see if it logically makes sense. Yeah.
Did you get 12 on the
What's that, sorry? The first one was 20, wasn't it?
When you say you got the 12, did you get the 6?
No. I got the 12 from here, and I'm saying to get this triangle, the smaller triangle, to be the bigger one, I'm timesing it by that scale factor I found originally. Okay? So can you see my calculation here? 12 times 5/3. Okay? All good? Then we only got 2 more questions. Oh, excellent. This was actually coming up in our list of things to cover as well. That's good. There are 3 secondary schools in Banley. The table shows the number of students in each of these schools. So the idea of stratified sampling is I want to go and ask 50 people. If I just went and randomly selected 50 people, if I just chose the first 50 names on the school register or something like that, then I could just get everyone from one college. It might be a really silly thing to do. Okay? So stratified sampling is a better way for me to work out how many from each school to take. Okay? So how many people are there in total? That's the first thing I need to find out. How many people are there in total? 50 who are selected. How many people are total in the schools? 700 add 750 add 900, which gives a total
2,400.
2,400, thank you, Lloyd. So if I'm to work out for Addis College, I'll just call it Addis, I would do 700. Are you change your answer, Lloyd? Sugar.
I don't add 950.
You didn't add. Oh, okay. So 2350. In Addis, there are 750 students out of 2,350. Okay? Not divided, you're very close. Fantastic. So you just multiply it by the 50, and that will tell me how many to take altogether from that college.
15
15, is it dead on 15?
is 15.95 recurring.
Okay, 15.95 reoccurring. Is it close to 15 or 16?
16.
Okay, 16. And why are we going to a whole
It will
number?
be close to 16 and then it's 15.
Definitely. Why are we going for? Why aren't we saying 15.9 then?
Because you can't put 9 percent.
Fantastic. Always thinking logically. Can you have 0.9 a person? No. So it doesn't make sense to do that. Okay, so how do I do the I can't even say that. Greslow, is it? Greslow. 700 out of the total. 2,350 times by 50. Okay, so should we have 14.8 people?
No.
Nope. What are we going to have?
15 people.
15 people? Yeah, agreed. And then finally for Fripp. Calculation I'm going to do?
950 over 2,350.
950?
Almost 959.
900. You could call what Lloyd had before. Give them an extra 50 people. Okay?
Where's Lewis?
So what's that give us?
19.1
19.1 reoccurring? Okay, what should we do just to be absolutely certain here? So 19 people? What should I do now just to be certain there's 50 people? Excellent. Add all those together. What is 16 out of 15 out of 19? Check it.
31.
Add the 19.
91.
50 students. Okay, it may be, so we've got our 50 students, so we're all done. Okay? It may well be that it doesn't add up to 50 just from the rounding. So you know where we rounded up and then rounded up again, and then rounded down. It might be that we've actually gone 1 over or 1 under.
So you didn't actually have to do the Fripp bit
Oh, okay, why not?
because it says we're going to choose from Glasgow high sample.
Oh, again, read the question. I just did a load of work we didn't need to do. Okay.
So the answer to it is 16.
If this was like a full-on question, if it was a full-on question on stratified sampling, what I would do is check the add up to 50 and say it went to 49 just from rounding issues, and it can do that. How would I choose who gets the extra person if it did go to 49?
Your favourite one.
Favourite one?
One with the most things.
Spot on, yeah. I choose to score the most amount of people. So if it went to 51 and I needed to take one off because I'd rounded 2 numbers up, the one with the least, I'd say, right, I'm taking one off. Fantastic. You've got the logic spot on there. Well done. Okay, so 15 people is the answer there. Oh, excellent. This is in our list of things to look at as well.
I hate that these.
Now, this is a hard question. This is not easy at all. It is trees. But you want... Oh, I don't know if... You've got 3 colours. Ideally, you want to do trees for two different options. But you've got 3. You can do it for 3. You just need to space it out properly. I am going to do trees. It probably is the best one. Very good. It doesn't.
Which makes it 10 times harder.
It does. It's an A-star question.
That's what I've got to do.
Well, okay, can we start getting something here? Because it's not about trying to get full marks on every single question. It's about trying to get some marks on most questions, okay? So, pens, red, blue, and green. So let's start off by doing red, blue, and green. Agreed? From how many red pens are there? Out of? How many in total? 5 out of 3. Yeah, add 2 is 10. How many blues are there?
3.
3 out of 10. And greens? 2 out of 10. Okay. Say I went and got red. So let's just double check. Make sure you listen now, please, boys. Sure, listen. Okay. Gary takes a random pen from the box, gives it to his friend, then takes another random one. So that means that pen hasn't gone back in. So if I selected a red, I could still go and get red, blue, or green again. But if I selected a red, there's only 4 reds left in the box, aren't there? Because
You've not put one back.
I've not put the red pen back. Does that make sense? How many pens are there in the box if I took one out?
9.
Excellent. 4 out of 9. Okay? Then, what's the probability I get a blue? Well, I didn't take a blue the first time, so there's still going to be 3 out of 9. And greens?
2 out of 9.
2 out of 9. Fantastic. Okay?
Would this be like one of the last questions?
Yes.
It's ridiculously long.
It does take long, but you've got 4 minutes roughly to be doing it, okay? We spent probably about 1 minute to read the question and start it. We're not far off being done now, okay? We've just got to be careful on thinking which pen's gone out of the box. So red, blue, green again. Now if I took a blue one here, I'm back up to 5 out of 9. Agreed? But the blue is now going to be 2 out of 9. The green would still be 2 out of 9.
How do you go back up to 5?
Because this option here, I didn't take a red out of the box at all. This option, I took a blue one out of the box. Make sense? What's that?
I don't get how it went back from 4 to 5.
So these are the different options that I could do. So here, the first option is that I took a red out the first time. Okay, so that's why the reds went down.
Yeah.
But we're ignoring that one happened. This time,
Oh,
instead of
right,
taking a red,
okay.
I took a blue out. Good. Ask questions. It's really, really important you ask. Okay. And then finally, from the green one, again, I can get red, blue, or green. And the chances of me getting so I've selected a green. That still means there would have been 5 reds left in the box. So that would be 5 out of 9. It means there would now be 3 out of 9 blues. And how many greens? 1 out of 9. Okay? Now, I'm going to sort of show you a shortcut in a second. Some people say I wasted an awful lot of time there, but my rationale is this can come up where you do have to look at all the options. It's asking that they were just the same colour. So in some respects, when I did my red, I should have only been interested in the red option. I didn't need to do the work for blue and green here. Vice versa here, when I chose blue, I was only interested in this blue line here, so I didn't need to do the red and green option. And when I took green, I was only interested in the green option again. So in some respects, this stuff here was wasted work, but it could come up in the exam as well, and that is 2 marks of what we've done already. Honestly, you've got 2 marks there already. Okay? So where you get the marks is that they check your branches add up to 1. So 5 tenths, add 3 tenths, add 2 tenths, comes to 10 tenths, which is 1. And then they check all those add up to 1, 1 and 1. And you've got 2 marks. How you're going to get the next 2 marks is choosing the correct options. So we're interested where they're both the same colour. So red and red, we want that one. Blue and blue, so we want this one. And green and green. So we only are interested in working out probabilities of those ones. So I've got 5 out of 10 here. And then I'm multiplying between the branches, 4 out of 9. Agreed? Put that into your calculator if you're unsure.
What's it? So what was it?
5 tenths times 4 ninths. Oh yeah, sorry. So what I was written here.
Not into 2
Do it as a fraction or make it
2 over 9.
2 over 9. This one here, what would be the probabilities I'm timesing together for B and B? Any ideas? Let me know.
It'd be red and
So B and B, so I'm only interested in going blue then blue, because I'm only interested in the same colour.
So 3 tenths and 2 ninths.
Fantastic. 3 tenths times 2 ninths. Again, put that into your calculator.
One over 15.
1 over 15. And then for green and green,
It'd be 2 tenths times 1 ninth.
fantastic. Syntax error, check again. It's important we know to use the calculator because if that happens in the exam tomorrow, we're in a bit of panic stations, aren't we?
It's in 1 over 45.
1 over 45, check you can get that as well.
What do you mean if it says syntax error?
You put it in wrong somehow. It's usually that you put like miss a bracket from somewhere, or you put like a times and then you not put like a fraction after it or something like that. Okay, so I've got all these different probabilities. I've got 2 ninths just off the screen, got 1/15th and 1/45th. So what do I do with those? Excellent, well done. That's your 4th and final mark from adding 2 ninths, add 1/15th, add 1/45th. Very impressive, well done. It's a hard question, that one.
Uh, 682 over 2,205.
Check again. Have you times or added?
Added.
Are you sure?
Yeah.
I think it'll be something over 45.
0.3. Oh no, wait there.
14 over 45?
14 over 45, yeah.
That's good.
Again.
Have you got any idea how I did that? Because obviously I didn't use a calculator, then I used my head. Well done, by the way. We finished the paper. I'll stop the recording there.